In this videocast, we'll take a look at salts and how they can have acidic, basic, or neutral properties. A salt is made up of two portions, a cation and an anion. And when a salt dissolves in water, depending on what the cation and anion are, a salt could act acidic, it could act basic, or it could act neutral. The question you need to answer to determine whether a salt will act acidic, basic, or neutral is where did the cation come from and where did the anion come from? You can think of a reaction as an acid plus a base always yields a salt plus water. This salt is composed of a cation from the base and an anion from the acid. And you have to ask, what were those parent cation and anions from the acid and base that made the salt? Because those determine whether the salt will act acidic or basic. Let's take a look at 6 easy rules that we can use to apply to decide whether a salt will be an acid or a base when dissolved in water. Rule number 1 says that an anion that is a conjugate base of a strong acid will not affect the pH of a solution. So rule number 1 is about anions, and remember, anions are the negative ion, or the Y that I've written up above here. If the anion came from a parent strong acid, in other words, it came from H, either Cl or Br minus or I minus or ClO3 minus or ClO4 minus or HSO4 minus, remember that's the anion of H2SO4, then these anions will do nothing in solution. They will do nothing in solution because they have no affinity to go and react with water and grab a hydrogen atom from them. Anions that are from strong acids don't want to become that strong acid again. They don't want to react with water to become that strong acid again. And so these will be neutral. Neutral. They'll do nothing in solution. So if they're an anion from a strong acid, they'll do nothing. Now I stress that strong acid part because rule number 2 talks about anions again. But this time, if the anion's parent in the salt is a weak acid, then it will act basic in solution. Will act basic in solution because the anion is actually the conjugate base of the acid. So take, for instance, C2H3O2. To find out what the parent acid of this anion is, just tack an H on it and say, oh, it came from acetic acid. Okay, then if it was, for instance, potassium acetate, when it breaks up, you're going to get some potassium ions. When the salt breaks up, you get some potassium ions and some acetate ions. Well, acetate ions in water are from a weak acid, and so it will accept a hydrogen atom, and it will form HC2H3O2 and some OH minus ions right here. The OH minus, of course, means that it's going to act basic. This is going to act as a weak base because it came from a weak acid. So if the anion came from a weak acid, then it's going to act basic. Okay, so now we've talked about 2 cases where anions come from. Remember, anions are the negative ion, and they're things like chloride, bromide, iodide, fluoride, acetate, chlorate, and perchlorate. Okay? If they came from a weak acid, if you tack an H on them and you don't recognize them as hyperhickel high, honohickel low, H2SO4, then they're going to act basic in solution because they're good acceptors of protons. And even though they'll have a double arrow here, double equilibrium arrow, they're willing to accept a hydrogen to make a HF and OH minus. Okay? So that's rule number 2. Rules number 3 and 4 deal with cations. These are the 2 rules about anions. Rules number 3 and 4 deal with cations, and I'll find another piece of paper here where we can write down rules number 3 and 4. Rule number 3 says that if a cation from a salt came from a group 1 or group 2 2 strong base, then it will do nothing in solution. No acidity or basicity. Okay? The cation is from group 1 or group 2. So if the cation was lithium, sodium, potassium, rubidium, cesium, calcium, strontium, or barium, all the ones that make the B on the periodic table. So if it was like cesium chloride or something like that, the cesium will not affect the pH at all. If it was like barium sulfate, for example, the barium ion, when it dissolves, will not do anything, although barium sulfate is not that soluble, is it? If it was calcium bromide, for example, the calcium ion, when it dissolves in solution, will do nothing. Will do nothing because it's a cation from group 1 or group 2. So if a salt has an anion from group 1 or 2, it will be neutral. Neutral. Okay? Rule number 4 has also to do with cations. This time, what it says is if the cation is the conjugate acid of a weak base, it will cause a decrease in pH. These cations you might not know so well, but here's a good example. Let's say it's NH4. Now this cation is from a weak base, and it's not one of these from group 1 or 2, and therefore what it can do in water is donate a proton, and it can act acidic. Okay? So if the cation comes from not a strong base like these guys, but from a weak base, okay, like NH3, then it can give away a hydrogen and it will form H3O plus on this side and some NH3. Okay, so you see how it acts slightly acidic, and it's going to give away a proton right there to the to the water. Some other examples of these types of protons are like, for example, CH3NH3. Okay, another example of a nitrogen-containing type anion. It's got to have a positive charge, and it's got to have a hydrogen that can give away. And generally, you recognize these by saying, "Oh yeah, they're cations, and they're not one of these. They're not one of these strong bases." Okay, so summarizing the rules now. First 2 rules are about anions. Remember, if the parent anion was from a strong acid, it's going to do nothing. If the parent anion was from a weak acid, it will act basic. If the cation was from group 1 or 2, one of the strong bases, it will do nothing. If the cation is from a weak base, then it will act acidic. So it kind of works a little bit backwards. 2 more rules. Rule number 5. Rule number 5 says that other metal ions that are not from the strong bases, so if it's not from the B ones on the periodic table, you know, lithium, sodium, potassium, rubidium, calcium, strontium, barium, if it's other ones than that, they will cause a decrease in pH, and therefore they'll be acidic. Okay? They'll be acidic. We'll talk about why these metal ions do that in the next video cast, but suffice it to say right now, if it's a metal ion that is in solution, it's going to act slightly acidic, a decreased pH. And then number 6, the very last rule, is that if both the cation and the anion will affect the pH, like for instance, let's say it's got NH4C2H3O2. NH4 came from a weak base, so NH4 positive should act slightly acidic, and C2H3O2 minus came from a weak acid, therefore it should act slightly basic. Then there's a competition between the two, and the one that has the higher Ka or the higher Kb will be the one that rules whether the solution is going to be acidic or basic. So, summarizing once again, the 6 rules. The 6 rules about salts. The 6 rules about whether a salt will be acidic or basic. Remember that a salt came from 2 things. It came from a cation from a base and an anion from an acid. Okay? If the cation came from a strong base, it will do nothing. If the cation came from a weak base, it will act acidic, kind of backwards of what you think. If the anion came from a strong acid, it will do nothing. If it came from a weak acid, then it will act basic because it wants to get back looking like that weak acid was. Last rule was that any metal ion that's not from a strong base, any metal ion is going to act slightly acidic. Okay, going to act slightly acidic. Those are the rules to keep in mind. Now let's take a look at some sample problems using those rules. What effect will each of the ions have on the pH of a solution? Each of the ions have on the pH of a solution. Now these ions could be thought of as coming from a salt. So NO3, NO3 minus. Where did that come from? Well, NO3 minus, parent acid or base was HNO3. HNO3 is a strong acid, and we said that an anion of a strong acid will do nothing in solution. So this will be neutral. Neutral. Did I spell that right? N-E-U, neutral. CO3, that should be -2, I believe. CO3 -2. Well, where did CO3 -2 come from? Well, that came from an acid, HCO3 minus or H2CO3, which is a weak acid. Now we said that if an anion came from a weak acid, CO3 -2, then it will act basic. Okay? How about K+? Where did K+ come from? Well, the cation, remember, came from a base. And what base did it come from? Well, if you're not sure, just take an OH and tack it onto it. Just like we did up here. If we weren't sure where NO3 or CO3 came from, just tack an H onto the front of it. And then you'll know what acid it came from. If it's a cation, tack an OH on the end of it and see if you recognize it. Well, KOH you should recognize as one of the strong bases. And we said that if an ion comes from a strong base, it's going to act neutral. Neutral. Okay? How about Fe+2? Where did Fe+2 come from? Well, it's a cation once again, and if you're not sure where the cation came from, just tack an OH onto the end of it. Well, FeOH2, did you memorize those? It was one of the strong bases? No, you didn't at all. So that means it is simply a metal ion, and a metal ion is going to act acidic in solution. It's going to act acidic in solution. We'll find out why next video cast. Al+3, where did that come from? Well, if you're not sure where cation came from, tack OH onto the end of it and see if you recognize it. Did it come from a strong base? No. Then it's just simply a metal ion, and a metal ion is going to act acidic in solution. So an easy way to answer these types of problems is if it's an anion, tack an H onto the front of it and ask what acid did it come from. If it's strong, if it's a strong acid it came from, it'll do nothing. If it's a weak acid it came from, it's going to act basic. For the cations, if you're not sure where it came from, tack an OH onto it. If you recognize it as a strong base, it'll do nothing in solution. If you recognize it as not a strong base, then it will act acidic. All right, next question. List the solutions in order of increasing pH. So we need to take each one of these and look at these salts and ask, where did the ions come from? Where did the ions come from? And of course, if they came from a strong acid and a strong base, they're going to act neutral no matter what the concentration is. Okay? Let's take a look at this one. Barium acetate. Where did it come from? Well, it came from barium, which would be barium hydroxide if it were a strong base, and so, or if it were a base and that's a strong base, so it's going to act neutral. It's not going to do anything in solution. C2H3O2, though, on the other hand, came from HC2H3O2, which is a weak acid. That means that C2H3O2 minus is going to act as a weak base. A weak base. So this solution should act basic because the barium's going to do nothing. The acetate is going to act weakly basic. Okay, now we have a 0.1 molar solution of NH4Cl. Take a look at this one. Where did NH4 come from? Well, if you're not sure where a cation came from, tack an OH onto it. And NH4OH, of course, would be a weak base. So it came from a weak base. You don't recognize it as a strong base because the strong bases, remember, are just the ones that form the B on the periodic table. And so this one will act slightly acidic because it came from a weak thing. The Cl, though, came from Cl minus, tack a H onto the front of it. You know, it came from HCl, which is a strong acid, so it should do nothing in solution. So this solution should act slightly acidic. Slightly acidic. Now take a look at this one, 0.1 molar NH3CH3Br. Ooh, looks confusing. Be okay with that, though. Deal with it. NH3CH3 is simply a cation that has a positive 1 charge. And if you don't recognize it, that's okay. If you even don't know the name of it, it's not a big deal. As long as you know that it's a positive cation and it's not one that is a strong base, then you know that it's going to act slightly acidic. Why? Because it's got a hydrogen it can give away. Br, on the other hand, came from HBr. HBr is a strong acid, which means it's going to act neutral. Lastly, KNO3. KNO3 is an easy one to deal with. K from KOH, which is going to be neutral because it was a strong base. NO3 came from HNO3, which is a strong acid, so that's going to act neutral as well, not do anything. So we have two things that are going to act slightly acidic, and we have one thing that's going to act slightly basic. So if we list them in order of increasing pH, the highest pH thing is going to be the thing that's going to act slightly basic. So I'd list this as number 1, or top, and if I went increasing pH, I'll list them down here below. I'd say the one furthest to the right would be my BaC2H3O2. It's going to be my highest pH, okay, the greatest. Then my neutral thing would be next, KNO3. And then it'd probably be a toss-up between these two because I'd probably have to look up the Kas of those two ions and find out which Ka is a little bit higher, NH4 plus or NH3 CH3. I'm just going to guess that the NH4 containing thing is going to be just a little bit more acidic. So actually I'm going to put that over here, and I should list the NH3 CH3 right here. So from smallest to biggest, smallest pH, this would be the most acidic. The second most acidic, this one would actually be neutral, and this would be my most basic solution. These two might be a little bit reversed, but do you get the idea that these two are both going to act acidic? Since I don't have the Kas in front of me, I can't tell for sure which one it's going to be. Last question of this video cast is to predict whether the salt of Na2HPO4 will form an acidic solution or a basic solution upon dissolving in water. So here's another salt question, just like what we did before. And you have to break the salt up into its two ions. The two ions it breaks apart to is to Na plus and HPO4 2 minus. There'll actually be two of these. And you have to ask the question, where did they come from? Na came from, if you're not sure, tack an OH onto it. Well, it came from a strong base. And what do strong bases, ions, cations do in solution? Well, they do nothing. So it's going to act neutral. HPO4 2 minus, where did that come from? Well, it probably came from H3PO4, which is a weak acid. And this is actually after it's dissociated twice. Well, what are the ions HPO4 minus 2 going to do from a weak acid? Well, they want to HPO4 2 minus attach themselves to hydrogen ions because they're only weakly acidic, and therefore they're rather basic. they want to take on a hydrogen to get back to this format of being a weak acid. And so it will become H2PO4 minus 1 and some OH minus. And when it does that with water, it's acting as a base. And so the solution will be slightly basic due to the anion coming from a weak acid. The anion coming from a weak acid. So, remember your salts. Remember your salts. Going back to the beginning, the salt came from a cation and an anion. Remember, if the cation came from a strong base, it'll do nothing. Came from a weak base, it will be slightly acidic. Anion, if it came from a strong acid, will do nothing. If it came from a weak acid, it will be slightly basic. If the cation just came from a metal that you have no idea what it's going to do, it's going to act slightly acidic. If both of them came from a weak acid and a weak base, then it's a toss-up, and it depends on the Ka and the Kb. Good luck with your salts.